Hello my dear students, welcome back to the one more session of structure of atom. So in the last session we have learned how to write the electronic configuration. Okay, so in this session we will learn about the valency, mass number, isotopes and isobars. Okay, first we'll study the atomic structure of the first 18 elements. So the first element is the hydrogen. So hydrogen has one electron. So it has only one orbit. Next is helium. Helium has two electrons. So in the first orbit only the two electrons are filled. You know the first orbit can occupy maximum of two electrons. Okay. So next is lithium. Lithium, it has totally three electrons. In the first shell, two electrons are filled and one more electron is filled in the second shell. Likewise, beryllium. So beryllium has totally four electrons. The first two electrons are filled in the first shell and next two electrons are filled in the second shell. So all these up to neon, there are only two shells. Okay, this neon, the second shell is completely filled. That is, it has 8 electrons. Okay, so the 8 electrons are filled. It is called as the octet. This shell is called as the completely filled shell. Means it has 8 electrons. So if you see the sodium, it has 3 shells. In the first shell, 2 electrons are filled, and in the second shell, 8 electrons are filled, and in the third shell 1 electron is filled. So likewise, if you see magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, so there are totally 3 shells. And argon, 3 shells are there, and second and the third shell, they are completely filled. Completely filled means there are totally 8 electrons. Okay, so these are the structure of the different elements. Clear? Next is valency. So what is valency? So it is the ability of an atom to lose or gain electron in order to achieve the noble gas configuration. Okay, so here which are the noble gases? Helium is there. Helium is a noble gas. Neon is there. Neon is a noble gas. Argon. Argon is a noble gas. So here valency means any atom, if it lose the electron or gain the electron to achieve the nearest noble gas configuration. Okay. Or you can say the combining capacity of the element with the other element is known as the valency. So it is obtained by determining the number of electrons in the outermost shell. Outermost shell, it is also called as valence shell of the each atom of an element. Take for example, here sodium is there. So sodium has totally 11 electrons. Okay, so in the first shell 2 electrons are filled and in the second shell 8 electrons are filled. Now 1 electron is left, that is filled in the last shell. So this last shell, it is known as the outermost shell called as valence shell. Okay, so in any element the last shell is known as the valence shell, and the electrons present in the valence shell are known as valence electrons. Okay, what are valence electrons? The electrons present in the valence shell are called as valence electrons. So here valency means, so this valence electron, it will combine with the other element. So one atom will combine with the same other atom or one atom will combine with the atom of different element, either by gaining the electron or by losing the electron. So this combining capacity is known as valency. So take for example sodium chloride. Okay, you know sodium chloride, it is a salt. The common salt what you use, that is the sodium chloride. So how this sodium chloride will form? So you know the structure of sodium, it is given here. If you take the structure of chlorine, so chlorine, the atomic number is 17. So how do you write a structure? So in the first shell 2 electrons will be there. Next shell 8 electrons. Okay, so totally 10 electrons are filled. Now remaining 7 electrons, they are filled in the third electron. So totally 7. Okay, so to become octet, octet means to become 8. So this chlorine requires one more electron. Okay, because in the outermost shell there are 7 electrons. So to become octet it requires 1 electron. Okay, and for this sodium, in the outermost shell only 1 electron is there. So to become octet it has to either gain 7 electrons, but it is very difficult to gain these 7 electrons. So what does this sodium will do? This will lose this 1 electron. Okay, so this electron, it is donated to the chlorine. So that will form the sodium chloride. So sodium will lose 1 electron and that is gained by the chlorine. Okay, so if sodium loses 1 electron, so it becomes octet here. And if chlorine gains 1 electron, it becomes octet. So then it forms the sodium chloride. So this combining capacity, it is known as valency. Clear? So here the valency of different elements are given. If you take hydrogen, so hydrogen, it has valency 1, and helium, the valency is 0. Why? Because, so if you take the structure of the helium, it has 2 electrons. Okay, so it has already reached the stability. That is, the maximum of electrons to be filled in the first orbit is 2 only. So the valency will become 0. So lithium is 1. So if you take the structure of lithium, so first shell has 2 electrons. In the last shell, 1 electron is there. So this lithium will lose this 1 electron. Okay, so the valency is 1. And beryllium, it is 2. Boron, 3. If you take carbon, so carbon atomic number is 6. So in the first orbit 2 electrons will be there, and in the next 4. So here what happens? So how the valency is 4 means, here in the last orbit 4 electrons are present. So to become octet, the carbon has to gain 4 electrons. Okay, either it can gain 4 electrons or it has to lose 4 electrons. Okay, but gaining 4 electrons is very difficult. It requires more amount of energy, and losing 4 electrons also it requires more amount of energy. So what does it will do? It will share the electrons. Hence the valency is 4. And if you take nitrogen, so nitrogen atomic number is 7. So if you see the structure, in the first orbit 2 electrons are there, and in the last shell there are totally 5 electrons. Okay. So to become octet, how many electrons are required by nitrogen? So 5 plus 3 is 8. So it requires 3 electrons. Hence the valency is 3. Okay. So here you have to do 8 minus the valence electrons. 8 minus valence electrons. Valence electrons means the electrons present in the outermost shell. Okay. So in the outermost shell of nitrogen there are 5 electrons. Hence 8 minus 5 is 3. So the 3 is the valency of the nitrogen. Okay. Same thing if you see the oxygen. In the oxygen the outermost shell has 6 electrons. Okay, so 8 minus 6 is 2. So the valency of oxygen is 2. So you have to calculate the valency like this. And if you take the fluorine, so in the outermost shell 7 electrons are there. So it is 8 minus 7 is 1. And if you take neon, so neon already in the last shell 8 electrons will be there. So 8 minus 8 is 0. So likewise all the other elements valence is given here in this table. Clear? So next we'll study about the mass number. So in Rutherford model you have studied that the mass of the atom is concentrated at the center. So what is present at the center? The nucleus is present. So in the nucleus protons and neutrons will be there. So the mass number means sum of the total number of protons and neutrons. That will give the mass number of an atom. Okay. Number of neutrons plus number of protons will give the mass number. So atomic number means the number of protons. Take for example carbon. So carbon atomic number is 6 and mass number is 12. Okay. And if you take the oxygen, oxygen atomic number is 8 and mass number is 16. And if you take the mass of the aluminium, atomic number is 13 and mass number is 27. Clear? So next we'll study about the isotopes. Okay, so what are these isotopes? So the elements which have the same atomic number but different mass number are called as isotopes. So in the nature, so there are many elements which have the same atomic number but different mass number will be there. Take for example hydrogen. So hydrogen, it exists in 3 different forms, that is protium, deuterium and tritium. So here protium means the hydrogen atomic number is 1 and mass number is 1. Deuterium means 2. So the atomic number is same here, it is 1 only. Only the mass number will change, it has 2. And tritium means 3. Atomic number is 1 but the mass number is 3. Okay. So such elements are called as isotopes. And one more example, carbon. So in the nature carbon exists in 3 different forms. That is carbon, atomic number is 6, mass number is 12. One more is there, atomic number is 6 and mass number is 13. One more, C6, 14. So these are the three different forms of the carbon. These are the isotopes of carbon. Okay. One more isotope is there, that is the chlorine. Okay. So this chlorine, it occurs in the nature in the two isotopic forms. That is, one chlorine has, the atomic number is 17, the mass is 35. One more, 37. So there are two isotopic forms of the chlorine. But how do you calculate the mass of the chlorine? So we have to take the average of these two, average of 35 and 37. So to calculate the average atomic mass of the chlorine, you should know the how much percentage of the chlorine is present in the nature. So this 35 chlorine, around 75% is present in the nature. And this chlorine with the atomic mass 37, it is present 25% in the nature. So if you calculate the average, so how do you calculate the average atomic mass? So 35 into 75 divided by 100, you will get around 26.4. And 37, if you calculate this chlorine, so 37 into 24.5 divided by 100, you will get 9.05. So if you do the average, it will be around 35.5. So the mass number of chlorine is 35.5 unit. Okay. So these are the isotopes. So this isotope, the chemical properties of all the isotopes of an element are same. Okay. But the physical properties differs. So there are some applications of these isotopes. So what are those applications? So the isotope of uranium. Isotope of uranium, it is used as the fuel in the nuclear reactors. It is used as fuel in nuclear reactors. So nuclear reactors means they are used in the nuclear power plant to generate the electricity. So the isotopes of uranium is used. And one more isotope, the isotope of cobalt. Isotope of cobalt, it is used in the treatment of cancer. It is used in treatment of cancer. Okay. And one more isotope, that is isotope of iodine. Iodine 131, it is used in the treatment of the goiter. Okay. So these are some of the applications of the isotopes. Okay. Next we will study about the isobars. Here isobars means the atoms of different elements with different atomic number and same mass number. Okay. So here opposite of the isotopes. In the isotopes, atomic number was same but the mass number was different. Here in isobar, the atomic number is different but the mass number is same. Take for example argon, calcium. So this calcium, the atomic number is 20 and the mass number is 40. Okay. And argon atomic number is 18 and mass number is 40. So here the number of electrons in these atoms is different, but the mass number of both these elements is 40. So if you compare calcium and argon, the atomic number is different. Atomic number of argon is 18 and calcium is 20, and potassium also. Mass number is 40 only, but the atomic number is 19. Here only the atomic number is different, but the mass number is same, 40. Okay, so such elements are called as the isobars. Clear? Okay, so this completes the entire chapter. Thank you.